Okay, sorry I can't be with you today, guys. What we're going to focus on in this lesson is dividing polynomials by long division. All right, so this kind of gives you an overview of what polynomial long division works like. It's very similar to numerical long division. It's just we're dealing with a polynomial. So hopefully you can get the gist of this through the video. All right, they want us to find the quotient and the remainder. So remember, the quotient is what you get, the remainder is what's left over. All right, so to divide this, I'm going to set this up as x plus 5 divides into 4x squared plus 23x minus 16. And one of the things that I want to make sure of is that no variables get skipped from standard form. So if you notice, it goes x squared, x, no x's. So I know it's in standard form. I asked myself the question, what times x gives me 4x squared? What times x is 4x squared? Well, that would be 4x. I'm now going to distribute the 4x. So I have 4x squared plus 20x. Just like in long division, I then take that term and subtract it. That allows the x squareds to cancel out or eliminate. I have 23x minus 20x, which is 3x minus 16, and I start the process over again. What times x gives me positive 3x? Well, that would be a positive 3. Distribute it to the x plus 5. That gives me 3x plus 15. I take that piece and subtract it away. The 3x's cancel out. Negative 16 minus 15 is negative 31. This value right here is my remainder. So unlike when you were doing long division with numbers, we would like add decimals and stuff like that. Once we get done with the polynomial, that just becomes our remainder. So the quotient here, which I'm going to represent as Q, would be 4x plus 3. The remainder is negative 31, but I need to write that as a fraction. So it'll be negative 31 over what we divided by, x plus 5. All right, and that's your quotient and your remainder. So let's try another one here. X minus 7 is going to divide into 3x squared minus 29x plus 56. What times x gives me 3x squared? That would be 3x. Distribute 3x x squared, minus 21x. Subtract that row away. That leaves me with negative 8x plus 56. What times x gives me negative 8x? That'd be negative 8. Distribute negative 8x plus 56. Take that row, subtract it away, and I get 0. This 0 is my remainder. So my quotient is going to be 3x minus 8. My remainder is going to be 0, or 0 over x minus 7. All right? So we have this thing called the division algorithm for polynomials, and what it basically says is, it gives us the right to be able to do this long division and be able to separate things into a quotient and a remainder. All right, so it's kind of just, I put it in here as kind of a summary, all right, of what we were just doing. The second thing that we can do with this long division is we can use these polynomial division to see if something is a factor. Now, something is a factor if when I do long division, the remainder is 0. If the remainder is 0, we know that that term is a factor. So this is kind of like a more difficult way to do factoring as opposed to like goal number factoring and stuff like that. Okay? If any terms are missing, remember we got to keep their place held by putting a 0 in. So they are now going to ask us, is this x squared plus 1 a factor of this quartic polynomial? All right? So here's how I'm going to set it up now. I have x squared plus 0x plus 1. I have to hold that place. And I want to see, does that divide into, whoa, that was ugly. Let me try that again. does that divide into 3x to the fourth minus 4x to the third plus 12x squared, but I notice, hey, wait a minute, I'm missing some things. 0x and then plus 5. So I look again, fourth, third, squared, first, none. I make sure that every missing piece is taken care of. All right? Sometimes I'll need them, sometimes I won't. But I want to make sure when I set it up that everything's accounted for. All right, so what times x squared gives me 3x to the fourth? That would be 3x squared. Distribute. I get 3x to the fourth plus 0x to the third plus 3x squared. And remember again, we have to subtract that away. So when I subtract this, the x to the fourths are gone. I have negative 4x to the third plus 9x squared, and then bring down everything else, plus 0x plus 5. Start the process again. What times x squared gives me negative 4x to the third? That would be negative 4x. Distribute. Negative 4x to the third plus 0x squared minus 4x, and I have to subtract that away. The x cubes are going to eliminate. I'm left with 9x squared plus 4x plus 5. Now notice it's a plus 4x because I had 0 minus negative 4. All right? What times x squared gives me 9x squared? Well, that would be a positive 9. 9 times x squared is 9x squared. All right? 9 times 0x is 0x. 9 times 1 is 9. I subtract that away, and I'm left with 4x minus 4. Now, can I multiply anything by 0x in order to get 4x? No, because if you notice this up here, I can't go any further, because if I multiply by something other than maybe a fraction or something like that, I'm not going to be able to get down to 4x. I got to be able to take a value off of that power. So, is this divisible? Well, maybe. How could I make a power disappear? Well, let's try this. What if I multiply this by 4 over x? Well, 4 over x times x squared, that's going to give me 4x. And 4 over x times 1 would give me plus 4 over x. So now I'm starting to get into this realm of confusion. Remember what the original question was. Is this a factor? I know right now it is not a factor. Okay, so let's try another one here. How about this one? I have x minus 2. They want to know if this is a factor of this polynomial. Some of you might be saying, why are you making that big division sign? I notice this is a quintic function. I have to hold the place of everything until I get to the minus 32. So I'm at 0x, here we go, minus 32. All right, so let's see here. What times x gives me x to the fifth? That would be x to the fourth. X to the fifth minus 2x to the fourth is what I get by multiplying that in or distributing. Subtract that away. And I get 2x to the fourth, 0x cubed, 0x squared, 0x, minus 32. What times x gives me 2x to the fourth? Well, that would be plus 2x cubed. That gives me 2x to the fourth minus 4x cubed. Subtract that away. And that leaves me with 4x cubed plus 0x squared plus 0x minus 32. What times x gives me 4x to the third? That would be plus 4x squared. Distribute, I get 4x cubed minus 8x squared. Subtract that away. I get 8x squared plus 0x minus 32. I'm almost done. What times x gives me 8x squared? That would be plus 8x. So distribute, I get 8x squared minus 16x. Subtract that away, and I get 16x minus 32. What times x gives me 16x? That would be plus 16. 16 times x is 16x minus 32. Subtract that away, I get 0. Yahoo! Because I got 0, I know that x minus 2 is a factor. Now, if x minus 2 is a factor, what's left? Well, what's left is this whole quotient right here. All right? So notice in the question it says write it as a product of two factors. Well, off to the side here, I'm going to write this. This is x minus 2 times x to the fourth plus 2x cubed plus 4x squared plus 8x plus 16. All right, do the best that you can here. Hopefully this video helps. I'll be back on Friday when we can talk some more about it.